Hey, I'm Anirudh. I work at Google on the container engine team, specifically on Kubernetes full-time. And this is Tim.
Yeah, I'm Timothy Chen. Used to be a Mesosphere, worked on Spark on Mesos. Now we have a startup called Hyperpilot.
All right. So we're here to talk to you about Apache Spark on Kubernetes, some of the work that we've been doing for the past 4 or 5 months, and where we're at this point. So the agenda is going to be, I'm going to tell you a little bit about Kubernetes in general, containers, Docker, etc., and then the motivation for this problem as to why we're trying to solve, trying to bring Spark onto Kubernetes, a little bit of a deep dive on the design, on how this really works, and then Tim's going to show you a demo of it actually working, a deep dive which explains what happened in the demo, and then like a roadmap of where we're headed next. So what is Kubernetes? It's an open source system. You may have heard of it. It's used for automating deployment, scaling, and management of containerized applications. So let's take a use case. You have a single application running on a server somewhere, and you just have a script to restart it when it goes down. You probably don't need Kubernetes. But you scale that out. You have 100 applications, and each of them has like tens of instances maybe, and they're load balancing, and you have all other requirements around it. At that point, you might want to think about cluster management and Kubernetes. Just to explain a little bit more about what I mean by containerized here, and it must be familiar to most people, but and we don't have time to go into the technical details of what containers are, but just to mention some of the advantages of using containers. You get repeatable builds and workflows. I'm sure a lot of people before this would have talked about this. It's like you get a prepackaged, you can package up all of your application and your dependencies along with it into this hermetic sealed package that gives you repeatable builds. You can store it in registries, version them, and so on. So it's going to improve your workflow. It's less DevOps load. It's just goodness all along. And it's also lighter weight than VMs, so you have improved infrastructure utilization. That's a good thing. Kubernetes is a pretty active project. It's one of the top 100 projects on GitHub, 23,000 stars, a lot of commits, and as you can see, the velocity is pretty damn high. There are lots of organizations involved, and these are not just organizations which are using it in production, they're also contributing code back to Kubernetes itself. So, and a lot of this, like Kubernetes stemmed out of Google's own experience running Borg internally, which is the container management solution. And a lot of those learnings have been channeled into Kubernetes. So an overview of what Kubernetes is and does. This is like the 10,000-foot view. I'll start from the right. So on the right are the nodes. The nodes run the user's containers. So if you launch something on Kubernetes, it's running on a node. Each node has a daemon called the kubelet. The kubelet's going to talk back to the special node called the master. The master has a bunch of things running inside of it. It's just a special node. And then the users talk to the master to declaratively specify what they want to run. So you say, hey, Kubernetes, run 5 instances of Nginx for me. And then the master is going to take that and then schedule your workload on the nodes themselves. So drilling down into the nodes, I kind of lied to you. They don't run containers. They run pods. Pods are like a higher level abstraction on containers. So a pod in Kubernetes is the lowest unit of scheduling. So a pod can contain multiple containers, 1 or more containers. The cool thing about pods is each of them has its own IP address. So if you have a pod in a separate node, in one node trying to talk to a pod in another, you don't have to worry about how you translate those packets through the network because the underlying system can handle that for you. And you can also have volumes, you can have network attached storage, and so on. Another cool thing is we have primitives that build on top of pods, which are controllers, which can create pods on the user's behalf. So you have stateful sets, daemon sets, and so on. Yeah. So the motivation for this problem is why even care about Spark on Kubernetes? A lot of organizations run Spark, run a lot of workloads on Kubernetes. They run serving and stateful workloads, databases, and so on. And bringing Spark and other data processing workloads onto Kubernetes gives us convergence. It's good for the IT folks because it's less infrastructure to manage. It's good for the developer because it's going to give you a single interface to manage all of your workloads, and your spare cycles can be utilized well, so that's improved infrastructure utilization. And on top of that, Kubernetes has a whole host of different add-ons and services that you can use right out of the box. And this is mostly because there's such a huge ecosystem surrounding both Kubernetes and Docker and the containers. So there's, for example, Istio is one project that was launched recently, and that takes care of a lot of the problems that people encounter often when running applications like auth and tracing, rate limiting, and things like that. So you get right all of that you can use with Spark on Kubernetes as well. So getting to the design of Spark on Kubernetes, this diagram must be familiar to most people who have used Spark. So you have Spark core, which is like this layer of abstraction which contains the RDDs and all the cool Spark things. And then on top of that, you have different libraries which do graph processing, SQL, machine learning, streaming, and so on. And then a layer below, which is what Spark core talks to, is different cluster managers. And these are almost like plugins. They're pretty disparate parts. So we added Kubernetes just alongside Mesos, Yarn, and Standalone as a cluster manager. And this is what it looks like. The dotted line separates the Kubernetes from the Spark. So Spark core cares about getting new executors, pushing new configuration, deleting executors, and so on. So we take whatever Spark core tells us, and our plugin that we wrote, which is the Kubernetes scheduler backend, is going to translate that into Kubernetes primitives so that the cluster can understand what you actually mean, like when you're provisioning executors and so on. In addition to that, it also handles resource requests, authorization and authentication, and just encapsulate all of the communication with Kubernetes. In addition to this, we had a few other components that we designed around the integration. So one of them is a staging server. So imagine you have you're running experiments, and you don't typically want to create new Docker images every time you want to change an input file, and you don't want to maybe host it in HDFS or push it there every time. So one thing that you might do is push your files onto this local staging server that we wrote. It sits inside the cluster, hosts your files so that your drivers and executors can actually fetch from that instance, from that staging server. So that's one component that we added. It's a standalone thing that you can add to your Kubernetes cluster. Another component is the Spark Shuttle Service. So this is essential if you're using dynamic allocation. So dynamic allocation is this mode where Spark lets you elastically change the number of executors as the job progresses, like depending on the number of pending tasks or in a particular stage. So that needs all the executor temporary files, the shuffle files, to be written to a different location because the executors are not long-lived. Like you might lose an executor because the Spark job scales down. So that's where the Shuffle service comes in. This is a component that is a part of Spark, and then we just used a lot of those primitives and then created an implementation for Kubernetes so that you can deploy your own Shuffle service and use dynamic allocation in Spark. Third-party resources, which are now going to be called custom resources in the next version of Kubernetes. This is a feature that exists in Kubernetes. This is used, it's part of the API, where you can add application-specific knowledge to Kubernetes itself so that you can visualize it in dashboards, in the console, and so on. So you can have your Spark job specifics, like the number of executors, how much progress you've made, and so on, be visible to Kubernetes as part of the API. So yeah, this shows kind of the different ways you can get your files into Kubernetes. One of them is you bake it into your container with all of the dependencies. It's one reproducible unit. You could just, every time you run it, you're going to get the same results. You could also stage the files in jars using the file staging server that we wrote, or the traditional ways of using Google Cloud Storage or S3 or HDFS. Those also work equally well. Getting to the administration point, Kubernetes has a lot of stuff in it that helps system administrators kind of manage the cluster really well. Namespaces, and we have integration for all of this in Spark Submit. because of the changes we made. You can launch into a particular namespace. You can have those namespaces associated with certain roles which have permissions, like a certain user could be allowed to create pods in that namespace, certain users may not. And you can have quotas associated with those namespaces. Audit logging, there are several third-party solutions, and there's also pluggable authorization and authentication. All of that can be directly used with Spark on Kubernetes as well. Yeah, so this word cloud kind of shows the different areas that we focused on. This is all the options that we added to Spark Submit as part of the effort. Just worth noticing here are the focus on like authentication, SSL, and so on. So this kind of goes to show that we paid close attention to SSL end-to-end and also the submission server. So yeah, that's kind of what we've done so far. I'm going to hand it off to Tim, who's going to do the demo.
Okay, so we will show a real-life demo of actually working. So before that, actually, I was curious. Who here is already running Spark with the cluster manager besides Standalone? So Yarn or Mesos, you're actually running it. Well, okay, most of you, probably I'll say 60, 70%. Who here is running Kubernetes already? Well, that's a lot of people. All right, so any brave souls run Spark on Kubernetes already? Oh, there are people, so this is great. So we will show you what a Spark native integration with Kubernetes means. So you probably expect the same thing you see from Yarn or Mesos native integration. So let's run an actual real demo here. So the job I'll be running is the Spark movie lens example using MLlib, right? So you can give it, in the movie data sets, if I have a personal ratings of some movies, can I actually recommend another set of movies out of this big set, which is more likely the ones I want to watch? All right, so I have a Kubernetes cluster. Let me break out of this really quick. I have a Kubernetes cluster. This is a typical Kubernetes dashboard. So we have different namespaces. We have a dev namespace, we have a prod namespace, right? So the good thing is about Kubernetes, it has all these primitives, namespaces, pods, replica sets. These are all available for us to use when you're talking about actually integrating with Kubernetes itself. So let's try to run a job in dev namespace. So this is what you typically would expect, right? So you can run a Spark Submit. Can you guys see this? All right, cool. Right, this is the typical Spark Submit you see. In this case, Spark Submit, we have deploy mode, cluster mode, the typical movie lens ALS. The most importantly, we're pointing to a Kubernetes master, right? This is if you used to be using cluster managers, there used to be Mesos, this used to be Yarn. Here, we're pointing to a Kubernetes master API server endpoint. This is what shows on kubectl cluster info. Because we're integrating directly into Kubernetes, we support namespaces right out of the bat. So you can say, Kubernetes, run this job in this particular namespace. And you can expect Kubernetes, the integration will actually set up and use the right namespaces. But all the other settings are what you've been familiar with, right? How many executor cores I'm going to use, what's the memory I want to use, what's the driver memory, what's the driver cores. These are all the same settings. Nothing changed from moving one integration to the other. So this is very powerful. You use Spark as is, pointing to Kubernetes. So let me just run this. This is the Spark with, with dev namespace. Okay. So we submitted this cluster, this job. Now
check the cluster.
I heard we're the first ones to actually do live demos today. So, this is probably need the refresh token.
Yes.
All right, this is what.
Kube control kit pods.
Oh, okay. I'm sure your experience will be a lot better. All right, let's try this again. So this is triggering the Kubernetes, Kubernetes exception. Sorry. It already submitted.
Exists.
Okay. This is different. Yeah. So might as well teach you guys how to use kubectl in the same time. Spark, movie lens. Yeah, so because we actually generate a unique ID for every job pod because it's easier for me to point to URL. I hard-coded a pod name here. But in this case, it should be better. Okay, now it's running now. All right, so the demo gods be with us today. So Yeah, so we then able to submit this job directly to Kubernetes as pods. So driver runs as a pod. It will also launch executors as pods. So let's look at the pod, the namespace of the pods. You see there's the movie lens job running. Here's the movie lens executor pods running. If you look at the logs of this pod, you see your typical favorite Spark logs that gives you all the nice information. Because Kubernetes also integrates with proxying, you can actually go to the Kubernetes, the Spark UI through the proxy. So this is, let me make sure I at the right place. Right, this is your Spark UI. I can directly go to, I'm using kubectl proxy on my laptop, right? So it's proxying to the master. So I can go localhost and look at this typical Spark UI that I like to see. So everything just works as is. So now you don't have to think about Kubernetes that much. Once you start running the jobs itself, Spark takes over, runs your tasks as is. So, if we do a similar thing running on a prod namespace, and hopefully this isn't correct. Maybe I don't have another pod running the same name this time. Hopefully not. Okay, we don't. Good. So it'll be running, and you can imagine that when you go to kubectl, you're watching your nodes. Kubectl get pods. On a dev namespace, you won't see the prod namespace's jobs, right? But when you go to the prod namespace, you should see our prod job running. So this is integrating this is super easy because we're integrating directly with Kubernetes features. So let's see. Yeah, if you want to see it again, this is pretty much the same prod namespace with the same prod UI. You can see your job running here as well. So yeah, so eventually you should also see the results showing up in this logs as well, giving you your favorite set of movies right here. There you go. All the movies you like. Okay, so that's our demo. Really quick to just show you that with the same integration we've done, similarly what you see on the cluster manager side for Yarn and Mesos, now you have an option to point to a Kubernetes cluster. And we can leverage the Kubernetes features to help running Spark. Namespaces, there's other features, other primitives that's available in Kubernetes that allows you to run Spark in a very more powerful way as well. But all the other stuff still feeling more familiar with what you guys will expect as a cluster manager. This is great. You don't have to run the standalone cluster on Kubernetes like what people will probably do right now. So a little bit back to a little deep dive. It's pretty simple. So when you run Spark submits, right, Spark submit, it goes to and submits, because we're running in cluster mode, it submits a job directly to the Kubernetes as a pod to run your driver pod. So this driver pod, we will, you can optionally support, talk to resource staging server if I want to upload my jar somewhere. I don't have HDFS running. I want to actually able to have my driver jars available. You can actually say, run this, specify this resource staging server. Here's my files. It will go to a resource staging server, and your driver will automatically download it for you. So this is a nice feature for you if you want to just run Kubernetes and have your jars available. So schedule a driver pod. The driver pod itself has the Kubernetes integration that goes back and talk to the Kubernetes scheduler, give me executor pods, right? You can specify how many instances of executors you want in your Spark executor instances configuration. It will ask the scheduler actually to say, please run my executor pods. And one thing to mention is because we're integrating with Kubernetes directly, all the scheduler features, it's not supported yet, but in the future, right, you have affinity, anti-affinity, all these things that are available at the Kubernetes scheduler side will be supported here. So if I want to say scheduler, executor pods, please only run on these nodes, spread them out, or anything that the Kubernetes scheduler supports, we eventually can also support that too. So that's the powerful thing of integrating with Kubernetes directly. So executor pods will launch up. Other dependencies, all your Spark configuration are forwarded, right, from Spark submit to all driver and executors, as you expected. The task runs as is, and once it finishes, all the dependencies are marked with the same tags and able to be cleaned up by Kubernetes itself. And so in the end, you also have a completed or failed pod of your driver that contains the logs for you to look at what happens, what is my results, or why does it fail. So if you have been using Kubernetes already, all the toolings that you have available for Kubernetes, for my logging, ingestion, or somehow to operate my Kubernetes clusters, those also are available for you. Okay, so now it goes on to the roadmap. We just really only started this not too long ago, actually. So, this is a pretty good progress. This is really the help of the community, really. That everybody's involved. So we support cluster mode. We also support dynamic allocation. I didn't demo it today, but because we manage a Shuttle Service for you, that means you can actually just run with dynamic allocation enabled and have it running. We have our own file staging server that the community has written just for Spark, actually, for Kubernetes. And we tested Spark SQL, tested Java, Scala support. Technically, GraphicX, MLlib, Spark Streaming, they all should just work. We're still in the process of trying to test them and make sure they're ready. But the next steps, we're going to definitely want to support the Python and R bindings. That's actually currently actively being developed by the community. Spark Shell, high availability, so things like how do I get my Spark streaming checkpoints, or all the HA features that you expect running Spark in productions, we will try to incorporate them as well. Cool.
All right. Yeah, so, yeah, thanks, Tim. This is the stuff that we're adding to Kubernetes in the coming releases, like some of the things that we've been working on. Custom resources, like I mentioned, are ways to extend the Kubernetes API itself. There are a lot of fixes coming in that direction. It used to be called third-party resources. It's now graduating to beta, and we're looking to add more features there. Priorities and preemptions for pods, which is going to lead to better sharing of a cluster between users based on priorities. That's coming as well. That's in the design phase. Batch scheduling and resource sharing. This is more for use cases like Spark, where we want to submit batch jobs and have it fairly share a cluster with other batch users, and also share it with real-time and serving workloads and scale down appropriately. So that's also being designed for the coming releases. And then we have cluster federation and multi-cloud, which lets you deploy workloads and then have them burst across different clouds, or manage multiple instances of Kubernetes on-prem and on cloud under one umbrella using federation. So that's also being worked on, and that's actually available, I think, in beta. Finally, Spark is just part of the equation. There's a lot of other things in the ecosystem that we need to work on. So Kafka, we have Helm, which is a tool used for packaging applications up. We have a Helm chart for Kafka, Cassandra, and HDFS. There's Pepper Data has been working a lot on HDFS on Kubernetes. We actually have a talk on that tomorrow. So yeah, the ecosystem is also coming along, and then we expect in the coming releases and by the end of the year, we'll have a lot of the parts of this entire solution filled in. Yeah, cool.
Yeah, so this is definitely a community effort, so there's lots of organizations involved. So in fact, most of this stuff around native integration is really heavily contributed by Palantir, Pepper Data, Red Hat, really actively involved. And we are actively also looking to merge this back to Spark. Right now, we're actually working on a separate fork because we want to make sure that all of that native integration is well tested and have our own velocity able to really get to a point where it's stable. And we're actively working with the Spark committers right now. They're all involved in discussions, and we are going to be also having the docs pointing to our repo very soon. So you can definitely follow these Jira tickets and our Kubernetes issues for better supporting Spark or even batch scheduling and big data in general on Kubernetes. So this is where our repo is at. Encourage all of you to really go and try it out. Right? Pull it down. There's a user doc repo that actually has documentation and a separate site for you to be available. So all the links are available there. And there's tons of activity happening. There's a lot of people involved, and I really encourage if you want to be involved, in discussions and contribution or testing, any sort of way. This is truly a community effort, so really want to be more people involved is better. And that's it. We have a SIG big data meeting. So Kubernetes have a special interest group meeting. And every week, Wednesday 10 a.m., we have a weekly Zoom meeting that if any one of you wants to be involved in Kubernetes or big data or Spark on Kubernetes, wants to be involved in the discussions, want to follow what's going on, feel free to join us. Most importantly as well, there's another session that's very related, right? HDFS on Kubernetes. Most people using Spark uses HDFS as well. How do you actually have data locality solved? That's also from the Spark side, able to know which executors to launch on which data nodes. There's supposed to be a talk. Pepper Data will be presenting their work tomorrow at 11 a.m. So that's our content. So we're open for questions. Or do you have any questions or anything?
Yeah, I think in the introduction you mentioned that you had been using Spark on Mesos or DCOS. Curious why, if you moved to Kubernetes because of any particular reason off of DCOS.
So you said out of what?
Just wondering why you moved to Kubernetes if you were using Spark on DCOS. Oh. What kind of the comparison between the two cluster management systems are?
Yeah, I guess. Yeah, so I think Kubernetes and Mesos, they are very different systems, right? Different communities as well. Kubernetes, is designed and built from learning from things from Borg and having the primitives available. Mesos is designed very differently, right? Mesos, two-level scheduling system, able to write your own frameworks. So there's a lot of customization of opportunities there, and I'll just say the communities are different. Kubernetes is, as you can see, there's a lot of momentum going on. Lots of people are starting to use Kubernetes as a resource manager. So I think it's going to happen no matter what. People that uses a cluster manager will also probably want to don't have a lot of different cluster managers they have to operate and learn how to operate each one of them. I think Kubernetes is going to be very interesting, where they already have a lot of support for all the long-running services. This is where they just started to learn how to run big data. So I think it's exciting time. I think we're not suggesting that this is production ready and everybody right now in production just move out to use Spark on Kubernetes right away. This is a very young effort, so that's why we want everybody involved. But I'm really excited that Kubernetes, with the primitives that it exposes, allows different opportunities for you. Because if you want pods, if you want replica sets, if you want those things, and you don't want to use a Mesos framework, right? Kubernetes is a good option here. There's definitely other options why you want to use Mesos. Maybe there's existing frameworks there. I don't think there is any conflict. We're really just different cluster managers altogether. So.
Hi. First of all, thanks for doing this, because I've been running Spark Standalone on Kubernetes for a while, and it's good to see that someone's putting another backend in, because for too long it's just been Mesos and Standalone and Yarn, so it's good to have something else. My question is, I asked the Kubernetes Spark meetup at lunchtime, I asked this, and someone said you might have looked at it, but they wouldn't be able to they didn't know off the top of their head. The different, obviously Spark, the Shuttle's a very network intense operation. Have you looked at the different networking backends like Funnel, Weave, Calico, and have you noticed any performance difference between them?
Yeah, there was a set of experiments that Pepper Data did, but more in the context of HDFS and Spark together. But yeah, we've been looking at the difference between using an overlay network, not using it, and how it impacts locality. So in terms of when your workload is, like when your Spark job is in the cluster and you already have your dependencies available to it, networking is not your biggest, it's not the biggest time consumer or the bottleneck there. But when you're fetching from HDFS, yes, it does become a little bit more of a constraint. There are detailed experiment results on the Spark repo if you want to look at that.
Okay, cool. Thank you.
One question. So how does the external shuffle service work with respect to Kubernetes? How are you thinking of implementing it?
So you say that again?
How does the external shuffle service works with Kubernetes?
The shuffle service.
Right. Today, the shuffle service is implemented in terms of, it's a daemon set. In Kubernetes, that's a primitive that lets you put one instance of a particular service on each node. So each node has a shuffle service, and it shares disk with the executor. But we designed it in a way that it is flexible enough that you could move to a model where you can have two containers within the same pod, and one being the Shuttle Service and one being the executor. So that's also possible in the current model. So we left it kind of flexible in that manner, but right now, like the default implementation uses a daemon set with shared host path volumes.
So the daemon set is basically like a set of daemons which should be running all the time in that particular node. Is that right?
I didn't catch that.
So the daemon set is basically a set of daemons which will be running all the time in that particular node.
Oh, yes,
Yes.
yes, yes.
Okay.
Yes.
But yeah, you could actually target a subset of the nodes using a node selector on Kubernetes, so that's possible. And it also gives you the added flexibility of having multiple Shuttle services. If you have different Spark installations which are not compatible with each other, you could have different Shuttle services for them.
Cool. One other question, like how long does the startup time take with respect to Kubernetes? Like Spark 7 startup?
Yeah, I think there's various factors because you have Docker images involved, right?
Right.
So there'll be a large time probably on a Docker image pulling side.
Oh, so it pulls the Docker images every time, like?
Yeah, it's running through Kubernetes, right? You specify the Docker image you want. Actually, I left out one big part is you specify what executor Docker image you want to use, what driver Docker image you want to use, and then it will run and download this. Kubernetes will do it for you. Download this Docker images down and run it for you. So, yeah, once you have the cache, it's probably a lot faster there.
Yeah, so if you're running the same job over and over again, the node's going to pre-pull that, like once it's pulled, it's going to cache the image, so you don't pay that cost multiple times if you're using the same driver and executor images.
Okay, so okay, cool, thanks.
So I'm just wondering for the
Sorry,
analytics.
excuse me. I think there are more questions, but the session's kind of over. So if you want, you can come up and ask the questions to the speakers here.
Okay.
And can we thank the speakers?